Hi students, welcome to physics session. I am Abhishek Sir and let us start our journey of chapter 1. Initially we have studied part 1 and part 2. In that we have seen few basic concepts starting from introduction of science, then we went for physics and various other branches of science also we have studied, various domains also we have studied, various scales of physics. Then we went for physics relation with other branches of science, how physics and other branches are interrelated. Then we went for a very important topic called physics, technology and society. In this we discussed how mankind has progressed and how in that progress physics has become very helpful. Then we went for the very important and the most important topic of this chapter, that is fundamental forces in nature. So in that, out of 4 fundamental forces, we started with the first force, that is gravitational force. So on the screen you can see introduction we have completed, tick mark. Scope of physics we have completed, physics, technology and society we have discussed. We started with fundamental forces, and here I have combined strong nuclear and weak nuclear, that is in nuclear forces. We are done with gravitational force. I hope you all have written all those 5 questions that I have given in the previous video. So today we will start with electromagnetic force, and then we'll go for nuclear forces, and finally we'll end this chapter with nature of physical laws. That will be again you have a homework for this topic. Okay, so let us go for the second fundamental force of nature, and that is electromagnetism. Now in 10th standard we had this last chapter of physics as electromagnetism. In that we studied how a very common observation of a scientist H.C. Ørsted became a very famous branch of physics that right now is known as electromagnetism. Now in that you studied that if current flows through any wire, it produces a magnetic field around that wire. Clear? So basically this whole field is related with flow of charges and how they create magnetic effect. Clear? Now in that chapter in 10th standard you also studied about few other concepts related to electromagnetism, that is right hand rule, Faraday's law, electromagnetic induction, solenoid electromagnets, etc. Now as we have already studied that, we won't be going into detail about all those topics. Simply as a part of short note on electromagnetism, I have some basic points that you need to remember. Remember that fundamental forces in nature, each forces must have 4 minimum points. Clear? Out of that some may be common, like what will be the definition, whether it is long range or short range force, what is the relative strength. Okay, so these basic points in all 4 forces you have to take care. Thus electromagnetism can be concluded that moving charges, they create magnetic effect, and these interaction between charges and effects, moving charges, that is motion of charges, and their effect, which is a magnetic effect. So these two combine to form electromagnetism. Very helpful for us. We will see the uses and utility also. Now starting with the first point, a force generates due to combined effect of charged particle and produce magnetic field. So this kind of force is called electromagnetic force. Now they are based on charges, right? And we know that there are 2 kind of charges, attractive and repulsive. Okay, now when do charges attract? When they are unlike. And when do charges repulse? When they are like. Okay, so this force can also be attractive or repulsive. Next point is, this force does not require any kind of medium. Okay, It is a long range force, as it is not dependent on any medium, so it is a long range force. Now this is a very strong force as compared to gravity. How much strong? When we are speaking about very strong force as compared to gravity, we know that gravity is the weakest force. So electromagnetism and electromagnetic force is very strong. How much strong? That is 10 raised to 36 times stronger than gravity. So these few basic points are related to electromagnetism, right? You have to note it down when you are preparing the notes. Now let us see in our daily life where electromagnetism plays an important role. So you can see in the figure we have almost 4 different diagrams or photos depicting the role of electromagnetism, and also more than those we have our own list of that we are using. See, electronic devices, we are using electromagnets, hard disk drives, speakers, the maglev train, which are considered to be the fastest, right? German made train, maglev, magnetic levitation trains. Electric bells also we are using, that is also based on electromagnetism. Motors, generators. In scrapyard also you can see this figure, the last figure. In scrapyard it is used to pick up heavy scrap metals, right? Talking about use of electromagnetism in medical field, so they are also used in MRI machines. MRI, whenever you have a problem in ligament, muscles, you have to go for an MRI scan. So they see our internal problems and internal organs by the help of machines called MRI machines, magnetic resonance imaging. Also, few atmospheric phenomena like lightning in the sky is also related to electromagnetism. We have completed the first two fundamental forces, that is gravity and electromagnetism. Now moving on to a combined set of forces, that are nuclear forces. In the second figure on the right side you can see two types of nuclear forces are there. One is weak nuclear force and another is strong nuclear forces. Both are nuclear forces only. And what do you mean by nuclear forces? They act within the nucleus. So guess what will be their range? Their range will be very less. Now where you can find weak and strong nuclear forces? So weak nuclear forces are responsible for radioactive decay of some elements, some subatomic particles. You might have heard radioactive elements, right? Now why they are radioactive element? Because they emit radiation, right? So what are exactly those radiations that they are emitting, right? That means some particles are coming out of their nucleus. So that is with the help of weak nuclear forces. And strong nuclear force, strongest force existing in the nature. They bind the component particles of an atom's nucleus. You see, in the nucleus we have variety of subatomic particles. Now why I am telling variety, as you might think that in nucleus we only have two type of particles, that is proton and neutron. Why sir is speaking variety? So you will come to understand when we study about weak nuclear forces. I will tell you some names of some more subatomic particles. Clear? So right now you understand that whatever binds the nucleus, inside the nucleus, neutrons, protons, that is nothing but the strong nuclear forces. Let us go one by one and let us see in detail. So starting with strong nuclear force. You have a figure just on the right side, strong nuclear forces. You can see few particles and arrows between them. The arrow shows that where the attractive force is applying, right? And that attractive force is nothing but strong nuclear force. Clear? Now let us see few points related to strong nuclear force. First point is, strong nuclear force is a force that binds together the protons and neutrons inside the nucleus. So this diagram is nothing but a short depiction of what is there inside the nucleus of any element. Okay. Next is, as this force act only within the nucleus, so we can write a point like this force is a short range force. Next point is, this force is 100 times stronger than electromagnetic force. 100 times stronger than electromagnetic force. Remember, electromagnetic force itself was 10 raised to 36 times stronger than gravitational force. So I am giving you a question, a task. Find out the relation between how strong nuclear force is stronger than gravitational force. Clear? Let us see whether you can calculate or not. If you get the answer, please mention in the comment section below. Moving on to the next point, that is, it is the strongest force known in nature. It is charge independent force. You can see from the figure, it is acting between proton, it is acting between neutron, and it is also acting between proton and neutron. So it does not depend on charge. Okay, so it acts between all the internucleus forces, particles. Finally, one question might arise that we have seen that it is acting between proton, neutron. Does it act on electron? No, as electrons are very far away from the nucleus, this force does not act on the electrons, right? Any utility of studying strong nuclear force? So scientists are studying strong nuclear force because it has helped them to manipulate these forces, and then they are using it in their own research work. For example, I have written 3 things below, not to be included in the notes, but it is for knowing. Scientists have manipulated strong nuclear force to improve the quality and magnitude of modern weapons. Okay, the manipulation of this force is the basis for the creation of nuclear weapons. See, right now we all are in the race of superpowers, right? So those countries having more nuclear weapons is considered naturally as a superpower. So this manipulation helps them into creation of nuclear power. Is also becoming a popular solution for energy crisis. Our next force is weak nuclear force. Now this force is very special because it appears only in certain processes, right? Now those processes, again, as I said, they might be beta decay of any nucleus. Now what is beta decay? It is nothing but a kind of radiation, right? When neutron splits into few subatomic particles, that is called decay. So we are not going into very detail, just see what points, if asked in an exam, what points can we write. So this force appears only in certain nuclear processes like beta decay of any nucleus. It is a very short range force because, again, after all, it is a nuclear force, right? Now this force, again, if weak word is written, don't consider it as very weak, because we all know gravitational force is the weakest. This is weak only is compared to strong nuclear force. Okay, now if we compare weak nuclear force with gravitational force, this force is still 10 raised to 25 times stronger than gravitational force, but ultimately it is weaker than strong nuclear force and electromagnetic forces. S and F stands for strong nuclear force, EM stands for electromagnetic forces. Now to understand this force in detail, that is again a very high level subject, we need to know about few elementary subatomic particles. Now remember, in the starting I told you that if I ask you what are the subatomic particles, you will say that in the atom we have electron, proton and neutron. But again, if you divide them, as John Dalton has said, that the smallest indivisible part is atom. Clear? But again we saw that atom can also be divided. Again, these subatomic particles, electron, proton, neutron, can also be divided. They are also said to be made up of particles called quarks, right? Then we have another subatomic particles called subquarks. Okay, they are said to be made up of few basic subatomic particles, right? So in all, if you study physics in detail, you will come to know that we have some special particles inside these atoms and electron, protons and neutrons. They might be neutrino, another name can be baryons, another can be mesons, leptons, hadrons, etc. So this is not our topic right now. You just have to remember few points related to weak nuclear forces. To understand in detail, we still have to go for graduation, post graduation. Clear? So this is how we complete these four fundamental forces. We studied gravitational force, then we studied electromagnetic force, then two nuclear forces, strong nuclear force and weak nuclear forces. Now another important topic that might not be included into a main topic, but this is very important, right? Now one of the basic quest of modern physics is unification of forces. Now what do you mean by the word unification? What do you mean by the word unification? Unification means unity, and unity means combination. Clear? So in short, unification of forces is combination of different physics and branches and concepts. Clear? So for example, I have given electromagnetism. We have studied in 10th standard. That is why you will easily understand that electromagnetism is the combination of electricity and magnetism. Clear? Now the greatest advancements of physics are only due to unification of different theories. How one theory is related to another theories, how from one topic we can go to another topic, how if we solve one mystery, that answer can be the solution of another mystery as well. Clear? Now a few scientists have done much work in this unification. So not forgetting the greatest scientist of physics, that is Isaac Newton. He tried to unify celestial domains and terrestrial domains. Now it is very important to understand that he made few laws that are known as gravitation laws and laws of motion. Clear? Talking only about gravitation. So gravity is a force which is present on our earth as well, and it also governs the celestial processes. Celestial processes means processes which are occurring in space. So if you want to study celestial motion, you have to study gravity. Again, if you want to study a motion of a simple ball which is hit by a cricketer, you will have to study force, laws of motion and laws of gravitation. So that is why gravitation combines the celestial and terrestrial domains. So that is nothing but unification. Okay. Same as Faraday and Oersted, they combined two separate branches and made electromagnetism. Maxwell, another good scientist, he combined optics and electromagnetism. Now even though you don't know much about Maxwell, optics and electromagnetism, how he has combined, you see, he told, and he was the first one to find out, that light is an electromagnetic wave. Clear? So light again shows particle nature, and light is also a kind of wave. Okay, so this was proved by Maxwell. We'll study about light later on when you will go for your post graduation in optics. You will study about the features and processes and concept based on light. Okay, so in total conclusion, efforts are still going on so that we can unite more branches of physics, and by that we can study the nature well, we can study the space and universe very well, and solve the mysteries of human beings. Clear? Moving on to the next part, that is nature of physical laws. Now this is the last topic, nature of physical laws. Now we know that in any physical phenomena which is governed by different forces, several physical quantities may change with time. Okay, several physical quantities may change with time, but while some special physical quantities, they remain constant with time. They do not change with time. Clear? So the physical quantities that remain unchanged with time are called conserved quantities. Right? They are the quantities which do not change. They remain constant with time in the nature. right? So laws of conservation of energy, charge, linear momentum, angular momentum, they are considered as fundamental laws of physics. Why fundamental laws of physics? Because they are the laws of conservation. They never change. They are constant, right? Out of these four, you might have studied till now. You might have studied only law of conservation of energy. Okay, and now law of conservation of mass is important for chemistry, but in physics we won't consider that. So right now we only know about law of conservation of energy. Let me tell you what you know about law of conservation of energy. The amount of total energy in the universe that remains constant. Energy can neither be created nor be destroyed. It can only be converted from one form to another. Clear? So this is law of conservation of energy. Let me speak out law of conservation of charge, linear momentum and angular momentum as well. But I'll be giving you another homework question that you have to find out from the internet the statements of law of conservation of energy, charge, linear momentum and angular momentum, or else you have to hear it very carefully, right? I will be speaking it only one time. So law of conservation of charge. During any process taking place in an electrically isolated system, the algebraic sum of the charges always remains constant. So we have a system which is totally isolated, right? And in that system, whatever charges are there, you add them, the sum will always remain constant. Next is law of conservation of linear momentum. If the resultant external force on a system is zero, the total linear momentum of the system remains constant. So without any external force, the linear momentum is conserved. So law of conservation of angular momentum is similar like law of conservation of linear momentum. We will study this when we will complete few chapters in physics. But right now I am telling you the statement: if the resultant external torque acting on the system is zero, the total angular momentum of the system remains constant, right? So these are the laws of conservation. Okay. Now in future you will study these laws in detail. In addition to these four laws, we have laws of conservation for spin, Baron number, strangeness, hypercharge, etc., right, in nuclear and particle physics. So right now we are not studying this. Okay. And now in physics, studies is carried out of space and time. In classical mechanics, space and time are considered independent of each other, while according to the theory of relativity given by Einstein, space and time are interrelated, right? So time again is a very valuable and precious physical quantity which is still a kind of mystery. Okay, so we know the basic reasons behind existence of these laws of conservation, but physicists are still putting their efforts to reveal the underlying mystery of nature in few laws of conservation, right? So dear students, the doors are still open for you to resolve many such interesting unsolved problems in physics. So that is how I declare this chapter as over. Okay, this chapter is over. The only writing work will be the short note on these four, as I assume that short note on gravitational force is already complete in your notebook. So you will continue with the second fundamental force, that is electromagnetic force. Then you go for strong nuclear, then you go for weak nuclear. No need to draw the figure. It is optional. If you want, then you can draw. And don't forget that I have told you to use internet and to write the statement of the laws of conservation. Clear? Now after every video session I'll be putting a Google form. This Google form link will be given in the description box which is below the video. So you have to go in description, click on the link, and this Google form will be compulsory because few questions I'll be asking you based on the videos, right? Suppose today this video is over, so I will have 5 or 6 question or 10 question based on this video only. So if you are watching these videos properly, you are easily able to answer those questions. Again, this Google form will help me to know whether you are, or whether all students are seeing the video, watching the video carefully or not. Clear? So this is a kind of feedback system that I will be putting after every video. Clear? So don't forget to like this video if you feel that it was knowledgeable. Clear? So that's all for today.